My website is cobradism.com, where you can find every way of contacting me known to humankind. I really mean it. I do want to start with an acknowledgement of country. I come from Belmont. It's a small city in the Bay Area. It is in the ancestral homeland of the Ramaytush or Loni people. And before I talk about how to build observable Python application, let's talk a little bit about what is observability. And so observability comes to us with the question, what is your application doing? You know, it's running somewhere, right? You probably write your code not to just, kind of look nice on GitHub, but to, run somewhere. So it's running, and it's definitely doing something, right? But what? And that's the question that observability comes to answer. What is my code doing? So why do you need observability? You can, I guess, ship it and forget it. But presumably, again, the reason you wrote your code and the reason it's running is because someone needs it. Otherwise, you just, contributing to global warming for no good reason, right? Oh, sorry, yes.
The mask.
Oh, so used to masks. Sorry, everybody. Okay, hopefully now I'm also sounding a bit better. So thanks, Grace. Still have to get used to the new world. Anyway, you can just ship it and forget it. But presumably, again, someone is using it, and maybe it's okay, maybe it's not. You probably want to make sure. Because if they're unhappy, at some point, it's going to matter to you. Probably better to know it sooner rather than later. And it's also a good way to get feedback, right? You ship that application. Maybe the person using it is happy, but is it doing what you think it's doing? Right? Are you happy with what's going on? You probably should be a little bit concerned about, are you okay with what's going on with the code? And you probably want to monitor, right? Someone asks you, hey, there's some issue. What's going on right now? You probably want to be able to pull up some data and say, oh, this is what's going on right now. Oh, there's actually a problem. Let me go and fix it, which is fine. Nothing is perfect. And you also want to get alerts, right? Ideally, it's not a human being who comes to you and tells you there's something wrong. By the time a human being has come to you, and probably there's been a whole bunch of humans have kind of talked to each other, and by the time it gets to you, ideally you want a more direct way, right? If there's a problem, you want to get automatically alerted. Again, you can decide what to do about it, right? Maybe it's not important. Maybe you can leave it until 8 a.m. if it's really late. But you want to be the one making the decision, not just, I'm going to hope it's okay, and if I wake up at 8 a.m. to a catastrophe, that's okay. Probably not. So you want all of that. All of that are good things to have when you assume that you write code for an application that needs to run and do something that's going to be useful for someone. So basically, the first way of observability is something we've all been doing since the first day we got Python, right? You wrote some Python code. If you're like me, at some point your Python code did not do what you expected it to do, even on your local machine. So you did the obvious thing, right? You added print statement at random saying, I'm in, after this step, and this value is equal to this, and you selected, oh, right, I forgot to data append, or that thing returns a new list, you need to assign it or whatever, and you did it, and then it worked, and then you remove the prints because you're I don't need these prints anymore. And the idea of logging, keep these prints in, right? So we don't want print in an application because maybe that application's std out is not owned by you and you don't know where it's going, and maybe it's going to dev null, maybe it's going to a place that will be super annoying. So logging is kind of the print you can't put in libraries. And why can't you put it in libraries? Because you have levels. So you can have different levels of logging. This is super important. This is just if you kind of really are digging into this stuff, you should probably look at that. And levels kind of try to answer what's going where. The only way levels can answer what's going where is if you have consistent semantics, meaning if you use info, it should mean the same everywhere you use info, because otherwise you can't put all the info stuff in one place and all the error stuff in another place. So you want consistent semantics, which when you write your application, you should probably have some clear guidelines and then make sure that people follow them. But there's one kind of people who are not going to read your guidelines, and because of that, they're not going to follow them, which is people who write lots of libraries on PyPI, and that's because they can't guess what your semantics are, right? I'm sure they would care, but they don't know, so they can't. So you're going to need to fix that. Luckily, Python gives us the ability to fix it. The logging library has a notion of a filter. Unlike what you would expect from a filter, this filter can actually change stuff. And luckily, it knows how to change stuff because we don't only get the level, we get the name, what's logging. The reason we get a reliable name is because this is how almost every Python module starts, right? Or like somewhere right next to the top, right? You import a logging library, and then you create a logger that's built on under name. Under name is a full path of your Python package, which means if someone wrote a third-party package, that's going to be a different path by definition because like your application files are different than that. So you can get the name, and then say, all the names that are prefixed with that stuff are coming from that PyPI library. So it's actually really important that whatever the semantics that library chose, even if they're different from you, are consistent. Because then you can map them to the semantics that you want, right? If they use always like info for that stuff, then you think that belongs in debug, you map everything from that library that's info to debug and so on. So you can do that, and then you have a coherent set of like what's going where again. So it is kind of annoying, but at least you have the tooling to do that, and you'll know very quickly if you haven't done it, right? If you don't see the logs you want to see in the places, you need to fix it. So even if you're writing a PyPI library, sure, you can't figure out what every application's consistent semantics are going to be. But if you are going to choose consistent semantics, then they at least can fix it. And again, like it's probably good if people in general agree on semantics. So these are the semantics that I like. If you like different semantics, like I said, you can always fix them. But as a suggestion for consistent semantics, here's what I like. So error means alert now. You'll notice that this means that you don't need critical because critical means alert now and error means alert now. So you can just have everything error, alert now. That's fine. This means an error is something that needs to wake someone up at 4 a.m. You don't want to wake up someone up at 4 a.m. Don't put an error log, right? You are the person who chose that, right? So you can just make the right choice. So what if something is going wrong, but it's not at the level that someone should wake up? So warning. Warning means alert in business hour. This is not a great set of affairs. Someone should be looking at stuff, but that can wait until business hours. That happens in midday Saturday. That's fine. People are gonna have fun in PyBay. When they get to work on Monday morning, they can check all the warning stuff that went on. Maybe you can automatically email it to them so they can get that email. But however it is, warning means someone definitely needs to look at it, but not right now, because this is not an okay. What happens if something is expected? That's info. Info means log it even if it's in prod. Prod tends to be kind of more scalable because it actually has to support your entire customer base. So info logs can get expensive because they'll be logged from every single machine. So again, you mean it, right? Like if you put an info on a thing, it means it's gonna, every time that step is reached in wherever you do production, that line is gonna be added, right? Like depending on, we'll talk later about where you store it, right? You need to figure out, is this worth the money? And this is literal money, right? Maybe it's very little money per line, but those things add up slightly. So this line that literally has a cost in production. That's fine because, like I said, observability is worth it, but you need to make sure that that line is worth the money. What if that line is not worth the money? That's absolutely fine. That's why you have debug. Debug is often in staging, right? Because in staging, again, you have smaller stuff. You can also have less kind of less of a backlog because nobody needs staging from 3 days ago probably, or whatever scheme. So you can probably again, that line of information is going to cost a lot less, so you can have more of them for the same cost. And staging is really useful because staging is probably where your worst code is, because you put it in staging, and if it's doing really badly, you probably don't deploy it all the way into production. You're going to fix it, so that's okay. Staging is where things go wrong more often. You want those debug logs to help you kind of work faster with QA. And again, depending on your ability to kind of, magically turn off and turn off switches in production, you might say, we can enable it in production for these specific machines for a specific duration of time. So maybe, I'm seeing weird stuff from that set of machines, right? Like the machines in the European cluster running the user service are doing something weird. Let's turn on debug. That's fine because it's not going to cost a lot. We're only turning it for a subset of machines, subset of the services for a short amount of time. But then we have this data and we can look at it and figure out what's going wrong with the European cluster of the user machines. So those warnings are those modes are very clear, right? When you write a line and you make the decision, you're like, should I wake up someone at 4 a.m. if this happens? No? Okay, definitely not error. Should I? Yes. Okay, error, I'm done. Should people get an email about it eventually? Again, yes, warning, no. Is this line going to be worth its money in production? Will it give people enough information about what's going on in the prod environment? Again, we all agreed, right? Observability is important, so that's good to be able to look. But if it's going to be a lot, probably not worth the money, so you make a decision. And if it's not, turn it on debug. And in general, my feelings about it doesn't matter how much you put in debug. Yes, at some point, you're going to have, probably that's too much. You're probably not going to reach it. If you're feeling at all uncertain about that logging statement, leave it in, move the mode to debug, that's fine. Once you're up in pod, if there's a little bit more stuff in the staging, who cares? However, remember that logging is going to get the log, right? So you want to be very, very careful about the information you log. You never want to use PII, right? Don't log any PII. That's, you can log user IDs because that's not PII. That's just a number. Do not log user names, user emails, passwords, and that kind of stuff if you don't know what PII is. And we want other examples. There's tons of training for PII. Don't put any PII in logs. Again, this is a hard and fast lose because if you put it, it will eventually get to the point where you will have to defend it in an extremely uncomfortable situation. The best way to not defend it in an extremely uncomfortable situation is not to do that. Okay. Same thing, right? It's gonna leak. Don't put it there. I don't care. And here's the important thing. It doesn't matter what level is. You can't say this is debug, so it's only gonna show up in production. At some point, this is gonna be enabled in production. I don't know how. But I can promise you, it's not an if, it's a when. And when debug is enabled in production, sure, it's annoying. It might happen by accident, and then you take up a lot of kind of money on the storage, but you'll fix it. You'll fix it in 2 hours, and sure, it was uncomfortable, but who cares at the end of the day? Unless you log something you shouldn't, in which case a lot of people are gonna care a lot. So it doesn't matter what the level is. Just don't log these things because they will make it in the production log. That will be your username and password, and at some point you'll get your company into extremely uncomfortable legal circumstances, right? So I want to kind of put it well out because observability is super important, but privacy is really important because ethics and also law. So once you put all the right stuff in the logger, again, our modern environments run stuff on tons of servers and tons of places and all over the place. You want to aggregate all of these into one places. So you kind of move all the logs from all the instances into one centralized server. Again, you can do that because you've already made sure that the levels are filtered correctly. So at that point, you've already accounted for the cost on the centralized server. So that's what I meant by cost, right? Again, you can run the server yourself. There's approximately 50 SaaS services that do that. Amazon has probably around 3 or 4 services that do that because that's how Amazon is. All of them are fine, right? Some of them are better than others in different ways. But what is common to all of them is that eventually you pay money for the storage of logs. It doesn't matter if you pay it in the form of buying a whole hard drive because you're doing it on a physical machine or doing it on a per line on a SaaS. Eventually, every line costs money. That's fine. That's part of the cost of doing business, but you need to think about what that cost means. And once you have the server, you can do queries. You can even do alerts at that level, right? You can say, if there's too many warnings in that level, clearly, like I said, every alert should be every error should be an alert because you already made a decision. Now you're just enforcing that decision. The error is actually alerting someone, and you probably also want other queries, right? You can even check the info data, right? And say, if there's more of these info lines per second, then that's probably bad, right? If I'm hitting the database too many times per second, that probably means the cache is out, and I probably want to alert on that. That's, again, perfectly reasonable. You can make the decision and figure things out, but you have a place to make those decisions, to kind of figure out what decisions you want to make, and then actually encode them into like a functional form. So when you kind of query logging, you usually want two things, right? You want to match on the details, and some of the details are structured, like the name, right? Because we already talked about like how the alerts are named, and the level, and there's also the time it happened and stuff like that, and the contents, right? You might want to like do a string match or some other kind of like arbitrary match, again, depending on what your logging aggregator gives you to like match stuff inside the alert. So you kind of have like this flexible query. But there's one thing that your library doesn't control, which is where it runs. So the other kind of parameter is the source. But again, like, the reason to kind of aggregate is because you have more than one instance. So you also can, like, say, again, only the things in the European cluster, or only the things that are running this server or whatever. So you have the source, which is like how it got into the logging server, and you have the data, and like, you query on both of these, some weird Boolean thing on all of these, and you get like some results back, like all the things that match that in the last day, and, depending on what you need it, you use it however you want it to use. So that's great. You have a log. So you already now kind of know what's going on. But there's a lot of stuff that, like, if you try to put in log, would be super annoying and unusable. So the next thing you want is to get into metrics. And kind of people have gone back and forth on the model of metrics, but I think now most people kind of standardize on that metrics probably like the best way to have some kind of scraping model, meaning at least as far as the application is concerned, right? You might have, it might not go all the way from like the monitoring source, but at least like as far as the application is concerned, it wants to be scraped. The reason is because this way you reduce like the decisions that you make at the application level. It doesn't need to figure out how often to send it, where to send it, all that configuration data doesn't need to fit in your applications. It can fit in a centralized thing, so your application can be simpler, and like all that logic can stay in like some metrics, thing, right? Again, like there's a bunch of metrics things, but they all kind of pull from your application and put it somewhere. So that's kind of like the server pull model, right? Like there's like, after it gets pulled from your applications, there's like 50 million things that can happen afterwards, and we'll talk a little bit about them. But from the perspective of your application, wow, you're doing metric scraping. If you're doing metric scraping, the thing I recommend is using Prometheus format, and that's because even if you're not using Prometheus, you're basically buying kind of, you don't care where it's coming from, because all the common metric aggregation systems support it, so you're investing in the future. That's great. I'm not going to go to the details of the Prometheus format too much, because you can basically use whatever wave framework you want, and like there's different things that I certainly do not have the time to go into. But then the other kind of things that is often confused with metrics is analytics. Analytics data is different from metrics because metrics should be constant amount of numbers, per like application, per unit of time. So in a given, minute, you should be sending more or less a constant-ish amount of numbers. Analytics are per transaction. So you say, per thing that happened. Right? It doesn't matter if it's a server, like clearly, like there's like, but even if it's a cron job, per like the thing that happens inside the cron job, that might be like a bunch of things, right? You might be grading a bunch of things and process each of them. So it's per transaction measurements, and so that means you can't actually send them until your kind of like logical transaction is done. So you kind of collect them all into like one big old ball of transaction data, and then you send them. A really kind of popular option right now is OpenTelemetry, and it looks good, but it's not there yet. Like if you actually look at the documentation, there's a ton of places where it says, this stuff is not finished, this bit is not quite done, this kind of stuff is like only halfway working, you need that format, it's not there yet. It's probably gonna be great in 2 years, but it's hard to predict the future. It's definitely not in the level that I would be comfortable running it in my cluster right now, just not there yet. So what's a good alternative? There's a bunch of commercial solutions, and you can probably read about them, but I'm not here to sell any commercial solution. One thing that people often forget, you can do structured logging, which means you collect all the data in a per transaction object, and you send it to the log, well, now you know what's going on, right? This should clearly be an info log. It should be in info and it should not warn people. And then you can like grab the data from the log collector and like do further analysis. It's not great, but it is not as bad as you think, because again, you can do queries to find the right things, then pull like some JSON data to your stuff, and then do like, kind of a bunch of collection. You can actually get like a reasonable dashboard out of that. The last thing I want to talk is error tracking. And a lot of people, again, try to use like, one of these other systems for error tracking, but errors are different in like very, big ways. So one of them is that you want to get very detailed data. Errors are supposed to be pretty rare. If they're happening frequently, the problem you have is not how you handle the load. It's like, why am I having so many errors, right? So they should be rare. And when they happen, you want to get tons of data, because that exception should not have been raised. If you accept this exception, you would have already handled it. If you got all the way to the point where it's an error, where it's unexpected, you want tons of data. Like I said, usually you hook into the exception handler. That's very classic in Python. One popular solution is Sentry. Sentry is not open source, but it's kind of open source, and it's close enough in that if you run it in your own environment, you can actually do it without paying any license cost, and you should run it yourself. And the reason I'm saying that you should run it yourself, detailed error data can be sensitive. Remember everything I told you about, like, passwords and PII and all of that stuff? That stuff is going to show up in your error logs, no matter how you fight it, because this is an exceptional case. Maybe the problem was that unintentionally you put the password in the wrong field, and that's what's going on. That means at some point it's going to have super sensitive data. If you put it in your own system, of course, you're gonna, put some guidance around it, but then at least, sending it to a third party that's way worse. Again, try not to put, sensitive data, but you're gonna fail, because if you were good enough at succeeding it, you wouldn't have had the error in the first place. By definition, the error happened in a place you didn't expect. So if you put all of these together, you get to a place where when you ask, what is your code doing, you get data, not speculation. Observability gives you knowledge, right? Knowledge is great, and knowledge is great for a lot of reasons, right? So it's a lot of investment. I described in very fast a lot of work that you'll have to do. Why? So first of all, it's great for testing, right? Like even from the staging environment, you'll get great data. When QA comes up with an issue, you'll have ways to analyze it. QA can directly pull this data and analyze and see if everything is going great. This is a great tool for improving your SDLC. You'll have better monitoring. When someone asks, what's going on? You're like, okay, here are the logs, here are the metrics, here are the analytics. Things are kind of okay. Or, oh, dear Lord, that thing is not good. But I think one of the biggest hidden benefits is onboarding, right? The old hands in your application won't need all of that. Give them a couple of logs. They've been through the code. They know what's going on. But we live in an industry with tons of churn, right? I'm sure we've all experienced all of that, right? That's fine. This is the industry, right? That's the world we live in. That means someone needs to join your team to backfill the person who just churned out. The quicker you onboard that person, the better off you are. If you can give that person all these dashboards, all these logs, all these analytics, they see what's going on. When they do a fix, they see what they fixed. When they have a bug, they won't have to go beg someone, hey, can you figure out what's going on here? Because I'm new in the team. And you just, here are the dashboards, here are the documentation to how to reach the dashboard. You should be able to look at it yourself. I mean, still help them, don't be a jerk, but they'll be in a better position to help themselves. And making more efficient onboarding, especially in an industry with high churn, means you're getting more value out of your developers. I think that is pretty much all the time I had and all the stuff I had. So thank you all.